Hi, I'm Matthew.
I'm Cindy.
I'm Tracy, and our project is Flash Clash the Speed Duel.
The project is a reaction time game where two players who press their button first when the light turns green will score the point for the round. But if they press during the red or yellow light, then the other player will get the point. When first entering the game, players can increment or decrement the winning score, which is how many rounds a player has to win in order to win the overall game. Then pressing both buttons at the same time will start the game. The first player to press their switch when the LEDs 1 and 2 turn green win the point for that round. If they were to press at any other time, the point will be given to the other player, penalizing them. The first one to reach the winning score will be the winner of the game. The LED 0 will turn the appropriate color, and a message will be printed onto the terminal for the appropriate player. Pressing both switches again will restart the game. Here's an example of players being penalized with the score going to the other player when they press when the light's not ready. The technical approach of our game is as follows. Our game is divided into two stages, the first being the initialize state, so players will indicate how many rounds a player has to win in order to win the overall game, and then actually playing the game. So users are able to communicate with our board using switches 1 and switches 3 on the board, and we know that a player has pressed on a switch using the interrupt handler. So in the interrupt handler, we have to know whether or not we are in the initialize state, whether we're in the normal game state, or if players have already won a game. So in the initialize state, pressing various switches corresponds to incrementing or decrementing the winning score, and pressing both switches at the same time corresponds to exiting the initialized state. If a player has already won the game, then pressing both switches at the same time will result in restarting the game. If none of these cases are true and we're in the normal game state, then pressing their switches will update their scores accordingly using the update score function. So within the normal game state, we use the play game function. Entering the play game function first turns on LEDs 1 and 2 to be red and turns on the green onboard LED to signal that our game is ready. We need two random values for this function, and we generate random numbers each time using the srand function. To see this srand function, we read the value from the light sensor to ensure that every time the random values that we get are truly random. So the first random value that we use is the random time that we use to wait until we turn LEDs 1 and 2 to green. When the LEDs 1 and 2 are green, that means that whatever player that presses their switch first will result in a win for that round for that player. But if they were to press the switch before the LEDs turn green or during a fake out LED, then the point will go to the other player. We also want to randomly generate when we turn on the fake out LED, so we also generate a random number 0 to 3, and if that value is 3, then for that round we turn on the fake light LED.
We ran into two major problems during implementation. The first major problem we ran into was that the game would sometimes move to the next state too early or too late. For example, in the play game function, the game would skip the round start state and move directly into the light on state. This problem occurred because the game would not wait for an interrupt to happen, but instead would run the play game function again, causing all of these lines to run before the interrupt actually occurs, and then once the interrupt occurred, you would be in this state. So to fix this problem, we have this empty while loop that blocks the game until an interrupt actually occurs. And this ensures that the game doesn't move to the next state until an interrupt happens. The other major problem we ran into was the LED and LCD libraries not work together because the LED sets the clock speed to 15 megahertz while the LCD sets the clock speed to 48 megahertz. To fix this problem, we let the LCD choose the clock speed of 48 megahertz and we update the LED functions accordingly. For example, in assembly for LED, we have to update the number of cycles between the transmissions of highs and lows.